So how does this monitoring workflow look in practice? So we start obsessing over performance, and that means that we will estimate the model performance if we can't, when we don't have ground truth, specifically for demand forecasting. If we have a very long forecast horizon, it's going to take a while before the actual demand becomes available, which we need to measure performance. And for that reason, we use a performance estimation algorithm. We have one in the open source library. And what this performance estimation algorithm does, it basically leverages the test set, and it goes and it basically maps which observations are tied to, or which types of observations are tied to which types of certain or uncertain regions in the model performance space. And then when the production data comes in, it can kind of map if there's more observations popping up in an uncertain region, then the estimated error is going to go up and we will speak of a degradation. And when that's the case, when there is a certain threshold exceeded, we'll have the data science team alert, and then we can look into perform a root cause analysis. Maybe some of the distribution of the model input features have changed, and tie in together what it actually is that caused the problem. And for demand forecasting, this performance estimation is specifically useful because, like I said, it takes a long time for the ground truth to become available, and it's only then that you can actually measure the real performance. So how does that look on a performance chart? If you would make predictions here, and this is your inference time, you would only really actually know what the realized performance is of your demand forecasting model of maybe a few months or a few weeks back. If you have estimated performance, you can actually already know at inference time how well your demand forecasting is going to do. And this is key because that allows you to act faster and actually act before there is a model performance issue. Because if there is a degradation alert, you can decide to then not execute the forecast, fall back on the previous model, maybe put something, so go and figure out, put things on hold, maybe take a heuristic approach, and not execute on things that you already know that are not going to perform well. And there's another reason why this performance estimation is so key in demand forecasting, and that's because covariance shift doesn't really work, or at least the traditional covariance shift detection. If you look at traditional covariance shift detection, where we look at how distributions change over time, it is already a very, very sensitive methodology because it's based on statistical methods where you only look at one feature at a time, and you apply many different statistical tests over time as well, and they're just bound to throw false alarms. And it's really all of these false alarms on a univariate level that make that if you don't use performance estimation, that you will get a lot of noise and lots of alert fatigue. And why is that specifically the case in demand forecasting? Because in demand forecasting, there's lots of trends and seasonality. And the traditional ways that covariance shift detection is set up with KS tests, they don't deal very well with seasonability and trends. And a seasonality effect or a trend effect might something be that your model just is allowed to deal with very well because it has observed those patterns in the past. And then you don't want to get an alert if you see that every other month the distribution looks like this, or that this distribution looks like that, while you're using here the gray distribution as a reference. Whereas technically, if you would be using just statistical tests, this would all be an alert while it is expected behavior, and your model knows how to deal with it well. And that's a little bit the way to look at covariance shift, is like if there's unimportant features that drift, your model might be able to deal with that very well. Then there's another point which makes covariance shift detection not very relevant for demand forecasting. And that's with demand forecasting, we usually aggregate lots of data. And when we aggregate lots of data, we lose data points and information. And that means that typically we just make predictions for a few products or for a few categories, and then it doesn't really have statistical relevance if you look at a few products, or if you look at a product level and the inputs related to that product that goes into the model. If you want to compare it with last time, you might not be able to actually construct a distribution. So for that reason, it's way more efficient to use a performance estimation algorithm where you focus on one metric that you communicate, that you track, and that you optimize for. And that's really the power that we see with performance estimation. And that's also kind of our opinion as the NannyML people on how to do monitoring demand forecasting models in production.